Welcome to Spelling Bee Ninja, your hub for free and engaging educational content. We're excited to have you with us today as we delve into the fascinating world of earth science. Our podcasts are designed to make learning fun and accessible for everyone. So, whether you're in middle school or just curious about our incredible planet, be sure to hit that subscribe button and join our community of eager learners. Today, we explore the rock cycle, a dynamic process that shapes our planet's surface and reveals the incredible transformations that rocks undergo over millions of years. The rock cycle encompasses three main types of rocks: igneous, sedimentary, and metamorphic. Each type forms through unique processes, showcasing the power of nature's recycling system. Let's break it down. First, we have igneous rocks, which form when magma or lava cools and solidifies. If this cooling happens beneath the Earth's surface, we call these rocks intrusive or plutonic. They cool slowly, allowing large crystals to form, leading to beautiful textural features. Granite is a prime example of an intrusive igneous rock, easily distinguished by its large crystals of quartz, feldspar, and mica. On the other hand, if the cooling occurs on the surface, we have extrusive igneous rocks. These cool quickly, which often results in smaller crystals or even none at all, like in obsidian, a volcanic glass that cools too rapidly for crystal formation. Now, let's shift our focus to sedimentary rocks. These rocks develop from the accumulation of sediments over time. Imagine layers upon layers of sand, silt, and organic materials compressing and cementing together, eventually forming solid rock. This process often takes place in water environments, giving us rock formations with fascinating textures and sometimes even fossils. For instance, sandstone forms from sand-sized particles, while shale forms from finer clay particles. The layering process is crucial, and sedimentary rocks are unique because they are the only type that can contain fossils, providing a glimpse into ancient life on Earth. Now let's talk metamorphic rocks, which form when existing rocks, be they igneous, sedimentary, or even other metamorphic rocks, undergo a transformation due to high pressure, heat, or chemically active fluids. This metamorphosis does not melt the original rock, instead, it causes recrystallization. Some metamorphic rocks exhibit foliation, a banding or layering texture, such as slate, which originates from shale. Others, like marble, do not show layering. Marble forms when limestone, which is primarily made of calcite, undergoes metamorphic processes. This journey through the rock types leads us to the concept of the rock cycle itself, a continuous process of transformation. The rock cycle illustrates how rocks change from one type to another. Igneous rocks can weather and break down into sediments over time, eventually forming sedimentary rocks. These sedimentary rocks can be subjected to metamorphic processes and become metamorphic rocks. Conversely, if metamorphic or sedimentary rocks are subjected to extreme heat, they can remelt into magma, which cools to form new igneous rocks. It's a cycle driven by both Earth's internal heat, like volcanoes and tectonic activity, and external processes like weathering, erosion, and deposition. Weathering involves breaking down rocks at the Earth's surface through physical or chemical means, while erosion is the transport of these weathered materials. Mechanical weathering physically breaks rocks without changing their composition. Think of frost wedging, where water seeps into cracks, freezes, and expands. Chemical weathering alters the mineral composition through processes like oxidation, hydrolysis, or dissolution. Then we have biological weathering, which occurs due to the actions of living organisms. For instance, plant roots can penetrate rock cracks, breaking them apart as the roots grow. Understanding these processes helps us appreciate the Earth's ongoing transformation. Now that we've established the basics of the rock cycle, let's look at specific rocks. Granite, a common intrusive igneous rock, is light-colored and features visible crystal grains. Basalt, on the other hand, is dark and fine-grained, often found in oceanic crust. Obsidian stands out as volcanic glass with no crystals, while pumice is known for its vesicular structure, which allows it to float on water. Rhyolite and andesite are extrusive equivalents of granite and basalt, respectively. The diversity of these rocks not only reveals the complexity of geological processes but also their significance in our environment. When we discuss metamorphic rocks, we explore their grades based on the amount of temperature and pressure they experienced. Slate, for example, is a low-grade metamorphic rock that originates from shale and can easily split into thin sheets, making it excellent for use in roofing and blackboards. In contrast, gneiss represents a high-grade metamorphic rock characterized by its distinct banding of light and dark minerals. Each metamorphic rock carries its own story of transformation reflected in its structure and composition. Moving on to sedimentary rocks, we find that they also come in various types. Clastic sedimentary rocks like sandstone form from rock fragments, while chemical sedimentary rocks like limestone precipitate from mineral solutions. Coal, an organic sedimentary rock, is derived from compressed plant matter. Each type offers insight into the environments and conditions under which they formed. For example, coal's formation is an indication of ancient wetlands teeming with lush plant life before being buried and compacted over millions of years. Finally, it's essential to revisit the rock cycle. This intricate web of transformations can be illustrated simply. Igneous rocks can weather into sediments which turn into sedimentary rocks. Sedimentary and metamorphic rocks can then be subjected to high temperatures and pressures to become metamorphic rocks. If conditions are right, those metamorphic rocks can melt into magma, which cools to form new igneous rocks again, completing the cycle. By understanding these processes, we gain a deeper appreciation for the Earth's dynamic nature and its capability for renewal and change. And remember, the oldest rocks on our planet, located in the Acasta Gneiss Complex in Canada, are dated at about 4.03 billion years. This tells us about the Earth's history and its incredible evolution. Our planet's surface is continually evolving, offering endless curiosities for us to uncover. Today, we discovered the rock cycle, a remarkable journey of transformation that rocks experience over time. We learned about the three main types of rocks. I think of them as nature's building blocks: igneous, sedimentary, and metamorphic. Each has its unique formation process and serves as a reminder of the Earth's dynamic processes. From the slow cooling of magma forming granite to the layering of sediments creating shale, we've seen how every rock tells a story. Understanding the rock cycle enriches our knowledge of Earth science and connects us to the natural world around us. Thank you for joining us today in our exploration of the rock cycle. We hope you found this lesson enlightening and inspiring. Don't forget to subscribe for more engaging educational content. Join us next time as we delve into another exciting topic that reveals the wonders of our world. Until then, stay curious and keep exploring.